The density of the fluid can be calculated. This is the mass divided by the volume. Okay, the next topic is the fluid. The fluid is a substance that can flow. This is the fluid. So fluid is based on the density and the pressure. So this is the density. The formula to calculate the density is equal to mass divided by the volume. The density of the fluid can be calculated. This is the mass divided by the volume. So in the meantime, you can also see the density. The density of the air is around 1.21 kilogram per meter cube. So this is the air density. Air is around 1.21 into 10 power kilogram per meter cube. Around this is the 20 degrees centigrade at temperature. And also the water. Water is around 20 degrees centigrade at the 50 atmosphere pressure. So this is the 1 into the 10 power 3. So this is for the water density. In the meantime, iron. So iron is 7.9 into 10 power 3. So this is the density of some substance we can calculate. So in the meantime, we can also calculate for the pressure. The pressure of the fluid is depending on the this is for the cylinder here. So this cylinder got the area A. So this is the fluid. We put the force. So force divided by area, then we can calculate the pressure. So that we can calculate pressure is equal to force by area. So this is the F divided by area A. So F is a Newton, area is a meter square. So this is the pressure unit Newton per meter square, so unit will be the Pascal. So we can calculate the pressure by this formula. Newton per meter square, this is the pressure. In the meantime, we also calculate for the pressure. So pressure also can calculate mass multiplied by the gravity. So that in this case, this is for the we can calculate for the pressure. Pressure is equal to force by the area. So this is for the force is equal to 4 is equal to mass multiplied by gravity. So in this case, if F is equal to mg, so the pressure P can be calculated mg divided by A. So the unit pressure is, this is for the 1 unit pressure for 1 unit area. A is equal to 1. So this is the unit pressure can be calculated by mg. Mass multiplied gravity, then you can calculate the unit pressure. In the meantime, mass is equal to the mass. Mass is equal to the density multiplied volume. So mass is m, density is rho, and the volume is v. So in the field of mass, you can calculate unit pressure is equal to rho multiplied v multiplied g. So this is the equation to calculate the unit pressure. Okay, so the living room has a flow dimension 3.5 meter and 4.2 meter. Height is 2.4 meter. So we have to calculate the volume of air, 1 atm. So that we have to calculate the price of air in the room weight. So weight can be calculated. The formula is rho v into g. So the air mass is 1.21 into 10 power kilogram per meter cube. So air is the density. The volume of the room is this is for the room dimension. Room dimension is room has a flow dimension. The flow dimension is 3.5 meter. Multiplying the 4.2 meter. So this is a 3.5 multiplied 4.2, and the height is 2.4 meter. And also gravity is a 9.8. So by solving this one, you saw that 420 Newton. So this is for the force of the air can be calculated. And B, find the magnitude of the atmospheric downward force at the start of your head. So area is 0.04 meter square. So in this case, our force is equal to, we can calculate air pressure multiplied area. Pressure multiplied area. So pressure is 1 atm. multiply area. So this is for the 1 atm, this is for the atmospheric pressure. Every 1 atm got the ratio is 1.01 into 10 power 5 Newton per meter square. So this is the air density divided by 1 atm. Normally 1.01 1 atm got 10 power 5 Newton meter square. So this is for 1.01. So in this case, air atmospheric pressure is 1.01. So there is the ratio around the 1.01 to 10 power 5 Newton per meter square. So therefore, we can calculate pressure ratio is every 1 atm got 1.01 into 10 power 5 Newton per meter square. So now that we also the 1 atm, so we can use the 1.01 and multiply area. Area is area of the head is 0.04 meter square. So by solving this one, you got to pay 4 into 10 power 3 Newton per meter square. So this is the way that you can calculate the 4. 4 is equal to 4 into 10 power 3 Newton. The fluid pressure at the depth H. So this is the container here. So this is the H. Here is a P0. So the fluid pressure can be calculated. So this one is the density. It's equal to rho. And the gravity is G. So the total fluid pressure P2. P2 can be calculated. P2 is at the point P2. Under the fluid surface. Under the fluid surface of the H, the depth H total pressure is a P2. The P2 can be calculated P0 plus rho into G into H. So this equation is to calculate the total pressure. So the P0 is the total pressure at the surface of the fluid, and at the depth H, you can calculate to the P2. P2 is equal to P0 plus rho GH. So this is for the total pressure at the liquid depth H. The property of fluid is when you are using the dip fluid here, and this is for the container here. So all the fluids they are same level. They ever go to the same level. So this is for the property of the fluid. This is what we can calculate for the interface here. The oil, and this is for the water. So this is for the interface Y. Interface Y all the pressure this is the true pressure. This pressure of the Y is downward, and this pressure of the water in the air is outward. So this is the downward pressure of the Y pressure. Outward pressure is the water pressure, and this is for the air pressure. So in this case, at the interface case Y. So this is the downward Y pressure. This is where this outward. So this is the water plus air pressure. So this is the equation we can write down. So in this case, we can calculate. So there's a downward interface pressure is PIND. PIND is equal to. So this is a P0, and here is a P water. So this is for the P water. So PW plus a P0. So the equation. So in this case, P water can be calculated. Water is here to here. So this is the air into T. So P interface equal to P0. Now this is the P water. P water is a rho H into the G into air plus D plus a P0. So this is for the we can calculate the P0 and P water. So P interface this is for the P water. So this rho H into so air plus D plus a P0 is the P interface Y. So in this case, we also calculate for this saturation point density and rho H. Point density it can be calculated. This saturation is the point density is equal to water density multiply to air by air plus D. So this equation. So I density rho A is equal to the water density into the air into A plus D. So then we can calculate the rho A. Rho A can be calculated. Water density is 1. So A is only know A is 135. Here A 135. D is 12.3. And therefore the rho A can be calculated as 915 kilogram per meter cube. So this is for the oil density can be calculated by this formula. We can measure the air pressure by the barometer. So barometer usually this is the barometer here. So this is the mercury. So the height of the mercury is you can measure this is the air pressure. So air pressure, the height of the mercury. So the air pressure P can be calculated. This is the rho into G into H. So this is the way that we can calculate air pressure by the mercury the barometer. Okay, the next topic will be the Pascal principle. So Pascal principle means all the liquid, all the pressures are equal. So this is for this two drums. This small cylinder and this is the big cylinder. The force on the small cylinder is F1. So this is area A1. Force on the big cylinder is F2. So this is the area A2. So in this case we can calculate this pressure is a P1 here. This pressure is a P2 here. So P1 equal to P2. This is the Pascal principle. When you press one pressure, all pressures are equally distributed. So in this case, P1 is equal to P2 according to the Pascal theorem. So P1 is equal to the F1 by A1, P2 is equal to F2 by A2. So F1 by A1 is equal to F2 by A2 according to the Pascal law. So this is why based on the Pascal principle that we can control the hydraulic jet. Hydraulic jet means that in the car workshop, we press a mechanic press a little force so that the whole car can be lifted by the hydraulic. So this hydraulic principle is utilized to the Pascal principle utilized to the design the hydraulic jet. Archimedes principle means that when any mass is any mass is they sink into the water. The second amount of the mass is removed. So this is what Archimedes principle. When you put this mass here, this mass is removed the equal amount of the water. So this is the mass removed the equal amount of the water, of the liquid, fluid. So this is for the Archimedes principle. This is according to the Archimedes principle. When any mass is they are sink in the water or any fluid, they display the equal amount of the mass. So this is for the basis principle. So according to Archimedes law, when a body is fully or the partially submerged, so this is fully or partially submerged, we put the body in the water or fluid. In the fluid, the buoyant force F2. Buoyant force F2 means that when you are put it here, so this buoyant force F2 is here. Surroundings are force. The surrounding force F2. This is for all the force are acting on this substance. So this buoyant force F2 is equal to the weight multiply weight of this substance. So this is the Mf. And the G gravity. So in this case, all the buoyant force is equal to the Fv is equal to Mf into G. So this is the equation to calculate the buoyant force. Buoyant force means that the force acting on this substance equal to this is the mass of the weight mass of the substance multiplied gravity. So this is the way that we calculate for the Archimedes principle. The substance into the weight. So this is for the fluid here. So in this case, we can put this as this. We use this is the meter, and we weight this as this meter. So we can also use the weight measuring equipment. We put in the distance there. So this weight is accurate weight. So this is accurate weight. Here is a wire force. So this is the wire force. Here measure is a apparent weight. For example, one mango that so the weight will be there. For example, 30 kilo, 70 kilogram. Okay, so this 70 kilogram is on the surface. Your body weight is around the 70 kilogram, but in the water, so you measure the weight. Your weight only there 50 kilogram because of buoyant force. So therefore, the apparent weight is equal to accurate weight minus magnitude of the buoyant force. Apparent weight is equal to accurate force minus a buoyant force. Magnitude of apparent weight is equal to accurate force minus a magnitude of the buoyant force. Bernoulli equation means that in the pipe. So this is the pipe line. So this is what is So this is the pipe all the fluids are moving. So this is the moving fluid. Okay, moving fluid means that we can measure. This is the height is H1 and this height is H2 like this. So here is the data height. H1, here are this line is H2. So this is data height. Okay, so any fluids are moving. So there's a pressure, force plus gravity, force and velocity is at the phase. So in this is the point 1, this is the point 2. The point 1, so there's a pressure is the P1. And the velocity half into rho into V1 square. And gravity force. So this is what is the pressure. So this is the pressure. And this is the velocity. And here is gravity. Gravity is that you can calculate the rho g into H1. So this is the gravity. So gravity force is depending on the height. So gravity force is a proportional to height. So the total pressure force at the point 1 is total pressure force is P1. Total velocity force is half into rho into the V1 square. And gravity force proportional to height that rho g into H1 is equal to at the point 2. Total pressure force is P2 plus a half into rho into the V2 square plus a rho g into H2. So this is called the Bernoulli theory. Bernoulli theory means that when there's a moving fluid must be moving. In this case, a pressure point 1 total pressure plus half into the density into velocity 1 square plus half rho into g into H1 is equal to at the point 2. So total pressure plus half into rho into V2 square and the rho g H2. So this is the Bernoulli theory. So then we utilize the Bernoulli theory to calculate the civil engineering the fluid calculation. So we use the Bernoulli theory. Okay, the next